بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. Hello everyone. Welcome to the first lesson of chapter 1 on determinants in our Algebra 3 course. I'm Dr. Asma Abada from the University Abdelhamid Mehri Constantine 2 Faculty of New Information and Communication Technologies. And in today's video, I'll be guiding you through this essential topic. I start my presentation by giving you the sections of chapter 1. The first section, definition and properties, we will see in this section the definition of an extracted matrix from another matrix, the definition of determinant, and the geometric interpretation of determinant. Secondly, we have the section 2, the determinant of a square matrix and properties. Here we will see the properties of determinant. Thirdly, we have the methods of determinant calculus. And finally, we will apply the knowledge of determinants in the inversion of a matrix. In this video, we will see a part of the first section only. At the end of this chapter, you will be able to recall the concept of determinants in both algebraic and geometric senses, explain the usefulness of determinant properties, including elimination of rows and columns for its calculation, apply the calculation of determinants in the process of matrix inversion, analyze the relation between determinants and matrix properties, combine the determinant knowledge to solve problems in other sciences, and finally evaluate determinants calculation methods for computational speed and efficiency. Next, we have a small introduction. The determinant is a number that we associate with a matrix. The determinant has a main role in the matrix calculus, solving linear systems, and the reduction of endomorphisms. We start our first section, definition and properties. In this definition, we have A is in the space of matrices of n rows and n columns, and its coefficients are in the field K. The field K can be the field of real numbers or complex numbers. That is the matrix AB squared, because the number of rows equal to the number of columns. Then we define the matrix Aij as the matrix extracted from the matrix A. How do we obtain this matrix? We obtain it by removing the row I and the column J from the matrix A. To better understand this definition, we have an example. Here, the matrix has three rows. We can say also lines, and 3 columns. We want to extract the following matrices. We start by the matrix A11. Here, we remove I here is 1 and J is 1. We remove the first line and the first column. The rest, which is 4 minus 5 minus 4, 2, is the extracted matrix. Secondly, A23. A23, here we remove the second row and the third column. The rest is the extracted matrix. And finally, A31. Here we remove the third row and the first column. The rest is the extracted matrix A31 from the matrix A. Here we have the definition of the determinants. The determinants can be defined as a linear application noted by F, defined from the vector space of matrices that has n rows and n columns, and the coefficients are in the field K, into the field K, satisfying the three propositions. The first, if the matrix is a single element matrix. Here, the matrix has one element A. The image of A under F equal to A. So if the matrix has one element, the determinant of this matrix is the element itself. Secondly, if the matrix is second degree, here we have the image of A under F is expressed as you can see. But what is F of A11 and F of A21? Here, A11 is the extracted matrix by removing the first row and the first column. We obtain the matrix that has one element A22. So the image of this matrix under F is the element itself. And same thing here, A21, we obtain it by removing the second row and the first column, we obtain A12. And the image of the matrix that has only this element is A12 itself. In the general case, that is, if the matrix is of degree n, then we have the image of A under F is expressed as you can see. The sum where I is fixed, J goes from 1 to n, and we can change. We fix J and I goes from 1 to n. What means we fix I or J? If we fix I, so I equal to a number of 1 to n. And G goes from 1 to n. If we change and we fix J, that is no change the result and the choice is qualitative. We will show an example to better understand. The first example here, we have the determinant of the matrix that has a single element, 4 is equal 4. And here, the determinant of the matrix that has a single element minus 7 is equal to minus 7. For the notation, you can note DET, parentheses, and here you write the matrix, or simply like this. We have another example. Here the matrix has 3 rows or 3 lines and 3 columns. We fix one of the lines or one of the columns. The choice, as we say previously, is qualitative and the result is the same. Let it be the first line. So I equal 1 and J goes from 1 to 3. Here we have the extracted matrices. A11, we remove the first row and the first column. The rest is the extracted matrix. A12, we remove the first row and the second column. The rest is the extracted matrix. A13, we remove the first row and the third column. We obtain determinants of matrices of degree 2. Here, to calculate this determinant, we multiply 0 by minus 2, minus 7 by 6. And same thing for the others. And we obtain our determinant. Thank you for your attention, and I hope my explanation of this part of the lesson was clear. Best of luck.